Hello everybody, welcome to this session of webinar. So we are going to start this webinar which is going to be held on construction stage analysis of PSC Girder bridge using Balanced Cantilever Method. So we are going to discuss with you and we are going to use the program of Midas Civil that is used worldwide. So I hope that you are going to enjoy this session and get new knowledge and improve your skill in using Midas Civil. Without wasting your time, we are going to start by a brief introduction about our company. So our company is called Midas IT, and the headquarters is in Korea, where I'm here now in the office. So the company Midas IT developed some software engineering software and sell the software all over the world. The main software we are selling all over the world is bridge engineering software, as we have a Midas Civil, and we have also for building structure analysis and design software. We have Midas Gen, Midas Engine, and other sub-software. And also we develop software in mechanical engineering and so on. But today we are going to talk about Midas Civil using this example on construction stage analysis of prestressed concrete box girder bridge using the Balanced Cantilever Method. So I hope that you can listen very well to my voice and we can keep going. For the content we are going to learn today, we are going to talk about the construction procedure of the free cantilever method. We are going to talk about the time-dependent material property. And the third point is going to be on the prestressed concrete box girder bridge modeling. And the fourth one is the detailed construction stage analysis. The last one is about the results, output, and interpretation. So when I perform this webinar and the previous webinar, I have to remind you one thing that you have to remember. So in order to use very well our software, you need to be trained. And in order to be trained, you can ask for training individually, or the company can send me the email, or can call me through the number I always do, or you can tell me through LinkedIn, as I usually use LinkedIn for communication with other contacts. So you can ask for training so you can know very well about the software we are selling here in the Midas Civil. And we do trainings and seminars online and offline, so all over the world, in Mexico, USA, Russia, Poland, Italy, Turkey, in India, and so on. So if you have any question or you want to be trained about our software, so please send me an email, and then we are going to discuss about scheduling the training with you. So as you know very well, the precast concrete box, how we construct this bridge we are going to talk about. So I know that you are skilled engineer there, so you do know the procedure we do to construct the prestressed concrete box girder. So we are going to talk about the sequence we use. When we begin the construction, we start by the substructure construction. And after the substructure construction is finished, then we can install the foam traveler on the pier. And after that, we need to go to the sequential completion of substructure construction, then the pier table form, scaffolding erection, and anchor divide installation. Then the installation of then we are going to install also the formwork, rebars, ducts, etc. And this one can take about 7 days when we are doing the construction. The other step we do is about the concrete pouring and the curing and post-tensioning of tendons. And this sequence can last 5 days. 5 days. And the next one is about the foam traveler. We can move the foam traveler from one place to another place in order to construct or erect other segments. We continue upon the completion of one span construction, then the foam traveler can move to another pier. Then scaffolding, shoring, formwork for end span. For the full staging zone, this is a mistake. Full staging zone is the end, and then the remaining part for the span, which is called for the full staging zone. We can use the full staging zone to construct the end part of the bridge. So, and we can construct also the key segment that can link two adjacent cantilevers. The next one is about the bearing installation and post-tensioning bottom tendons, and then bridge surface construction, and then the finishing construction. So these are the steps that we do when we are erecting the prestressed concrete girder using the FCM method. So the material we are going to use is the concrete and tendon. Those are the main material we are going to use, and the property we have, they are on the screen. I cannot read all the property we have, so we are going to go a little bit faster, so we can use the software for the practice for the demonstration. So we have the top concrete and the property of the top concrete. We have the allowable stresses. All of this data are going to be used and input in the software. The bottom concrete, we have for the design concrete, the compression strength is about 270 kilogram force per centimeter square, and its modulus of elasticity is given. So about the tendon, we have the yield strength of the tendon, the tensile strength, the cross-sectional area is given also, the modulus of elasticity, the inductive post tension, the anchorage slip also is given, and the friction loss coefficient also. They are given for, they are just the data we are going to input when we are doing the modeling. And the load we are going to consider in the construction stage analysis, we have the dead load. And you all know that the dead load is the main load that is applied during the construction. So the self-weight of the structure is the main loading. And we have also to apply the pre-stressing force. And we have information about the tendon. We have the cross section of the tendon. We have the duct size, and the pre-stress load was set to 72% of the tensile strength. All of these are going to be applied in the modeling. And we have also the loss immediately after taking. So this loss is calculated by the program automatically. And we have also for the final loss is also calculated by the program. And when I say final loss, I think about the relaxation and the loss due to creep and shrinkage. So these functions are calculated directly in the software automatically. You don't need to calculate them by hand, but the software gives the answer automatically about the relaxation and loss due to creep and shrinkage. These are the conditions we are going to use when we are going to define the creep function and the shrinkage function using this code of CEB FIP, the code we usually use in Europe. So the other information is about the form traveler load. So in Midas Civil also we consider the form traveler load is applied when we are doing the modeling. So for those who watched my previous video about the introduction of Midas Civil, I said that in Midas Civil we can model the structure using 3 different methods. The first one was the node element method when we design, not design, but when we do the geometrical modeling of the structure, we use a node element. And the other method is about the wizard. The wizard function in Midas Civil, they are really powerful. They can auto-generate the structure without struggling. And the other one is about importing the drawing from AutoCAD and other programs, so you can import the structure modeling using AutoCAD and other programs that are compatible with Midas Civil. So the method we are going to use in this webinar, it's the really fast one, which is the wizard method. So in Midas Civil, we can use the FCM wizard to model the free cantilever method bridge. So the layout of the construction segment is there, and you can see that we have three span of our structure, and in this place we have 12 from the pier toward to the key segment. We have 12 segments, and then the key segment, and then comes the full staging method, where we use the full staging method zone. So the other point, it's about the construction schedule. So before every construction, we need to make the schedule. So this graph shows the construction schedule we are going to use when we are going to analyze and design our bridge using the FCM method. So you can see that the first pier here, and this one is the second pier. So the duration of construction between these 2 piers is 60 days. So these piers were not constructed at the same time. So, and you all know that when you don't construct 2 members at the same time, they have different properties, and their shrinkage and creep, they are really different because they don't have the same age. So based on those variations, when we are doing the construction, Midas Civil is able to consider all of the variation we have when we are doing the construction. So even if 2 members were not constructed at the same time, so, and those members will have a different creep and different shrinkage and deformation, they will be different because of the duration of the age of the concrete are not same. Midas Civil can deal with those variations very well using the FCM wizard. The next one is the graph showing the arrangement of tendon. So this is how the tendon will be arranged in the section. So this is the end span tendon placement, and on the right we have the center span tendon placement. And this figure here shows the section at the middle span, here, and you can realize that the section at mid span it's not deep, but the section for the pier is really deeper compared to other sections. And when you specify these two sections, Midas Civil is able to generate automatically the tapered shape that will be formed between these two sections. So when you specify the middle section and the section at the pier level, so using those two sections, Midas Civil is able to make the tapered section, the girder, based on these two sections. And that curve is a second order curve that Midas will automatically generate to make the tapered segment. So it's really fast and automatic. We are going to see it when we are going to make the model. The next point is about the layout of the tendon, how the tendon were pre-stressed. We have the top tendon and the bottom tendon. So I'm going to go a little bit faster so we can go and use the software. And these are the sequences of the construction. We are going to use Midas Civil, and we are going to talk about different results. We have stresses and member forces, and we are going to check also the stresses with construction stages for the pier table, and these are the movement variation based on each construction stage. And you can check also the results using table. You can check the stresses using table, and you can import even this table to Excel without struggling. And we can also check the prestressed load graph and the deformation at specific construction stage. And then the camber control also, the result can be also checked in Midas Civil. So we are going to use the software so we can understand very well how Midas Civil can handle the prestressed concrete box girder using the FCM method. So I'm going to open Midas Civil. Okay, if you have any question, you can prepare the question, and then at the end of the simulation, you can ask the question while I'm opening the software. I hope that you can see my screen, and Midas Civil is on the screen. So we are going to start our modeling. As you can see, this is the window of Midas Civil. So to start any project, you need to set the unit you are going to use when you are doing the modeling. So for the unit system, we are going to choose the unit that are prepared. It's meter and kilo and ton force. Those are the units are prepared for this example. And we need also to check about the material. To input the material we are going to use, we go to the menu property and then material property. So we can define the material, section, thickness, for the element, but in this case we are going to use only material and section option. So here we are going to use concrete. We select concrete and we can give the concrete the name, and the name for this concrete is C400, and we can select the code for this concrete. We can use even KS Civil. You can select any code you want. Even we have Euro code also. It's on the list. BSRC, you can select it when you're going to select the concrete. So I select Korean standard. You can select from the DBC 400, and you can see that the mechanical property of this concrete is automatically entered here. And then we can click on apply. The other concrete we're going to use is C270, and we can select it from here, C270, and we click on apply. And then we are going to define the last one is we can define the tendon. We are going to check. We are going to put the mechanical property of this tendon. We have 2 times 10 7 here, and then the Poisson's ratio is 0.3 because it's steel, and the thermal coefficient is 1. The exponent is minus 5, and the weight density of the steel is going to be 7.85 ton per meter cubic meter. So these are the property we are going to use for the tendon, and then we click on OK. These are the material we are going to use, and for the section here we are going to click here, but we are going to input this part using the wizard of the free cantilever method. So here we are going to go to the wizard. In the structure menu, you go to structure menu and then you click on FTM bridge. It's free cantilever method, but in other countries they usually use balanced cantilever method, but here in Korea they usually use the free cantilever method. So you can, the balanced cantilever method, you know, is the same as the free cantilever method here. So in this box, in the dialog box, we have 3 tabs here. So we need to complete this information the software is asking. The information related to the model, the section, and then the tendon information. So when you input all of this information here, after putting all of this information and then you hit on OK, then the software will generate automatically the geometrical modeling. So we are going to start by the model. So these are the numbers, just the default file we have in the software. But because I have the file that I saved, and that file contains all the dimensions we need to use in this demonstration. So I'm going to call that file, and then I'm going to explain a little bit faster because we don't have much time here. So I'm going to call this file and open it. So when you are inputting this data, you need to check this picture here. You need to look clearly closer to this picture, and then you input the value based on the picture you see on the screen, the picture of the section, the transversal section. So in the material we just defined previously, is C40, 400, C400, and C270. You can check them here in this line here. The three material we just defined. So that's why I said that it's better to define the material first. But even if you didn't define using the method I just showed you, you can click here on these 3 points here, and then you can define the material. The same dialog box can appear here, and you can click on add and define the material the way we have done previously. So this is not a big problem. And the material we are going to use, they can be easily selected without any problem. So because I have the file, this file is prepared, and the data I have here, they are the data we are going to use in order to analyze our bridge. So we have the concrete for the girder is C400. The concrete for the pier is C270, and then the number of piers we have. I showed you the layout of our bridge as two piers. So for the section, the pier section, we have only one, and the stage duration of we have 12 days for the stage duration. And this 12 duration is the 7 days. The 7 days I just explained when I was explaining the sequence of construction, and 5 days for the curing of concrete and the removal of the formwork. So 7 plus 5 is the 12 days here, the stage duration. So each stage is 12 days, as explained previously in the PPT. So if you want to use the curve girders, you need to check the radius here. And if you have just straight girders, you don't need to put the information about the radius. So in our case, the girders are straight, so we don't have curved here in this example. So for the other information, pier table, PT is pier table. This is the height of the pier table, and this is the width of the pier table. K1 and K2, they are key segments. Key segment 1 can check on in this picture. Key segment 1 and key segment 2. So their length is 2 meters. And for the pier, we have the height of the pier is 40 meters, and the C is the distance between the two pier here from their center. So the distance between the two piers here is 4.2 meters. So for the other area of the bridge, the FSM, for the full staging method, we have the distance of the segments we have in that area is 2 meters, and then we have 4.25 meters repeated. We can repeat this value 4 times in this area of FSM. So if you want to model a bridge that has the bridge that is not symmetrical, you can activate these advanced. So if you want to put advanced information, you can activate advanced and put the peer table. If the bridge is not symmetrical, you can add also this information about the peer table. And for key segment also, if you have different geometry of the key segment, you can input the information here based on the geometry of the key segment you have. And for the in this zone also, for zone 1 and zone 2, if you have the segments that are not equal in dimension, you can activate advanced, and then you click on this button advanced, and then you can specify the length of the segment you are going to use in this zone, when in the zone of the bridge. So this is the first step for the model. After inputting all of this data, you can check also the peer table placing. So when I told you that the first peer and the second peer, they weren't constructed on the same days. So after 60 days, then they started erect the second peer. That's the meaning of this duration. So the time between the construction of peer 1 and peer 2 is 60 days. That's the meaning of peer table placing. So the other, for the member age, you need to specify the duration of the member, of the concrete member, for every segment you have, and the peer table also, you need to specify the total days to construct these members. So for the segment in this area of FSM, the total days to construct them is 60 days. So when I say the age of the concrete, I mean when we remove the formwork from the beginning of the construction until the removal of the formwork. That's the age of the member. That's the age I'm talking about. So those duration, you need to also to specify them in the software when you are doing the construction stage, because they are really important in this area. So you can, after inputting this duration, then you click on OK. Because I had the file containing the value that I need, that's why I don't input them. But if you don't have those values, you can input them manually. It's really easy. So this is the first tab of our model. For the section, it's really easy. You take this picture and you input the data related to this dimension is shown in this picture. And because I have already input these values, so we don't need to re-input them. As I explained before, Midas Civil used two sections, the mid-span section and the section right on the pier, to generate the tipped section of the girders. So when you put this information, Midas Civil is able to generate the sections that are between these two sections using the method automatically, and that shape will be a second order curve when you are going to make the the segment, the taped segment. So in Midas Civil also we take account of the form traveler load, and we include also the form traveler load in the calculation. And the load we have here, we have this load P and the eccentricity here. So using this data, Midas Civil will calculate the nodal load that will be applied at the end of each segment when we are doing the construction stage. So these two data will help us to calculate the nodal load that will be applied at the end of each segment. So we can, after finishing this section, we go to tendon. With tendon, we need to input also the geometry of the section. But if you don't take this box, then the software will not consider tendon in the calculation. So in order for the software to consider the calculation, in order the software to consider the tendon in the calculation, you need to check this box, tendon and prestressed, and then you have to input this dimension according to the picture you see here. And this is the arrangement of tendon in the section. So I showed you this arrangement in the PPT, so you can refer to those information to input this data here. And I talk about also the checking stress. The checking stress, we took 72% of the ultimate strength of the tendon. And for the bottom and the top, the checking stress is same. So the other important thing we need to input also the tendon property. For that, we need to click on these 3 points here, and then we have to define the tendon property. And the tendon name, number one, will be top. And the tendon type we are going to use is internal post tension. So in Midas Civil, we have 3 types of tendon. We have internal post tension, we have internal pre-tension, and internal post and external. So you can choose among these type of tendon when you are doing your modeling. So the material we define is tendon. We need to select it, and the total area, I explain it, and the value of this area is the diameter is 15.2 millimeter, and then we have the number of strand is 19. After inputting those data, then you click on OK, and then the software will calculate automatically the area of the tendon, the total tendon area. For the duct diameter is 0.103. And for the relaxation coefficient, we are going to use Euro code. Is the code we use in Europe, CEBFIP. And we are going to use the ultimate strength is given automatically. And the curvature friction factor is 0.3. The work of friction factor also, we are going to take 0.01. And then for the anchorage slip is 0.006 for the beginning and the end. And the band type is banded. After doing that, we can click on apply, and then we define also for the bottom. We can put the name of the tendon we use at the bottom section. So the name is butt, and we We select the same tendon type, the same material, the area they are same, the code they are same, and then all the stuff they are same. So we can click on OK to define the property. So for the top, we need to select top, and for the bottom, we need to select bottom. After doing that, we need to precise the number of tendon anchored in each segment. So to do that, we need to click here on the top tendon here. Because I've already mentioned the number of tendon anchored in each segment, I have those value here. And when we click on the segment number 1, then you can put the number here and then click on define to input this number here. It's very easy. If I want to change the number of segment 2, I select segment 2 and then I input here 2 and then I click on define. Then the number of segment 2 can change like that. But let me put the number that was there is 1 and then I click on define. It is one tendon is anchored in segment 2. After this precision about the number of tendon anchored in each segment, then you can click on OK. Then you need also to precise the tendon at the bottom. You have to specify the number of tendon anchored at the bottom of the section. Similarly, you have to precise also the tendon anchored at the bottom but in the middle section. And then you have to click on OK after defining this number of tendon anchored in each segment. After that, you need to specify the anchorage position. The anchorage position you can see in this picture. You can see the definition of X is between 0 and 1. So here we consider the anchorage position is at 1 meter. And then the top tendon grouting, we consider that is going to be at every 1 stage. For the tendon number, you need to make also to precise also the number of tendon that you are going to use in every part that you have specified where the tendon will be. So you can see on this picture, number 1 through number 8, and then you need to put the number of tendon you are going to use for N1, N2, N3, N4, N5 through N8. So these arrangement of the tendon I showed you in the PPT. So these numbers, they are the number that I mentioned on the PPT when I showed you the layout of the arrangement of tendon. After inputting this information, then you click on OK. And that's all we need in order to generate the geometrical model of our prestressed concrete box girder. So if I click on OK, you can wait. So the software can generate the model easily. So this is our bridge we are going to analyze. Okay. So it's really simple to generate when you enter those information in that widget and to generate, and you need to change this information based on what you want to get, and to change the loading and the boundary condition and the structure group, you need to be in this mode of base. So when you are doing the construction stage analysis using Midas Civil, when you want to put some change, make sure that you are in this mode, base mode. But when you are in this construction stage mode, you cannot modify the geometry, but you can modify the loading condition and boundary condition here. But for other modification, make sure that you are in this mode base, so you can make the modification of the loading modification, boundary condition, and the structural group modification. So in order to go a little bit faster, I'm going to explain the following section using the file I have already prepared, so we can continue a little bit faster. So this is to change this color is really simple. You can go to display, and then you go to I can click here on the display option, and then you go to draw, and then you select section, and then you click on random color. If I click here and then I hit on apply, the color will change here depending on the section I'm using. So that's what I did when I was preparing this file. That's why you saw different colors on the screen. So this is the model that Midas Civil generate automatically using this FCM bridge widget. So we are going to make some modification of the construction stage number 13. So to check the construction stage, we can click on construction stage 1, 2. We can keep clicking on the construction stage to check how the structure was constructed. Okay, let me use the base mode. So if you want to check the layout of the tendon, then you can go to display, and then you click on miscellaneous, and then you click on tendon profile point, then you click on OK. So you can see how the tendon was arranged in the section like that. So if you want to see it clearly, you can zoom in one part you want to check clearly. So you can check very well the tendon defined in the wizard we have just used. So this is how we can check the tendon profile. Okay, we can also check the load. The load applied in every construction stage. We can consider stage number 1. These are the load. If you want to see the number of the load or the value of the load, you check load here and then click on apply. These are the value of the load based in the construction stage number 1. Okay, we can go back to base. We can hide these so we can continue the analysis. The next point we are going to check is about how to modify the stages we have made. When we define the construction stage, you can go to the menu load and then construction stage, and then you click on define construction stage. From this stage here, from this dialog box, you can change the duration of the construction stage. For example, if I want to change the duration of this construction step number 6, I select this one and then I hit on show and modify and show. Then if I change 12 to 20, I have to input here 20. And then if I want to change also the load on this construction stage, I have to click on the load tab here, and then I need to specify the load I can add to the active day or inactive day. So when we're doing the construction stage, we have to activate some group. So you need to activate and deactivate the structure, the boundary condition, and the load, depending on the the construction you are doing. So you need to activate and deactivate some structure members, some boundary condition, and load depending on the construction stage you are doing. So for this to change the step here, I have to introduce here we have 20, and then here we select it, can put 8. So if I want to change the step of this one, I have to enter the day here and then to check the days here, and then for the load also I can check the number of the duration put here, it's 8. And if I want to change for only this one here, I have to select this for the PS1 to 5, or I can use this the wet concrete here. I can select it and then I click modify. Then for this group, the duration will be 8 days. But this is just an example. I'm showing you how to modify this, but I'm not going to apply it because what I prepared is the right duration. So I will not apply it, then I click cancel. So that's how we can modify the duration after generating the model, the geometrical model of the bridge. We are going to continue. Okay, you can modify. You can see for other construction stage we have 12 days. For construction 15 we have 13. And then this one is for creep. When we are going to check creep function, we are going to check the creep at 10,000 days, the creep and the shrinkage coefficient at 10,000 days. That's why we have some differences in the duration here. So these are the modifications after the generation of 12 days duration. So I did modification on the stage, construction stage 13, and then 15, and then 16. These are the only modification I did after the generation of the PSC box girders. So we can close this one. We can continue with the modeling. We didn't finish it yet. We can check the group that we activate in all our structure. Query, and then we need to click on the group activation of construction stage. So where you see 0 means that this part is activated in the construction stage. So the activation is represented by 0. So this is the graph that indicates the activation of the loading, the boundary conditions that are activated when we are going to do the construction and analysis. So we can check other information also. These are for the boundary condition, for the boundaries that are activated at the construction number 1 through construction 16, construction stage 16. And we can check also the structure that are activated in every construction stage. So you can click on element. Element is structure, elements, boundary, and then a load. These are the activation and deactivation. You can check the deactivation is specified by X. So that's how we define the group, the loading group, the boundary condition group, and the structure group. The next thing to do is to define the creep and shrinkage function. So they are the time-dependent property of concrete. So to do that, we need to go to property, and then we go to creep shrinkage. And for that, we need to add the function we are going to use. So as I already defined 2 functions, but I want to show you how to do that in order to go a little bit faster. So here you have to put the name. Let me put creep, and then I can select the code I'm going to use. After selecting this code, then I have to specify the compressive strength of the concrete at 28 days, and I have to put also the relative humidity is 70%, and the national size of the member I can put 1 meter, and then I select the type of cement. I can use the default one, and the age of concrete at beginning of shrinkage I can say that is 3 days. After doing that, I hit on apply, and then I click on yes. Then I have created one function here, one function that is called creep. And similarly, you can input this data I already input in the software. So you can click on C400. You can check the value I used for the condition I showed you in the PPT. And to show the results of the curve, is this the curve of the creep coefficient and time. And if you want to check also the strain curve, you can check the shrinkage strain also easily in the software. So that is how we can define the creep shrinkage function in the Midas Civil. So I'm going to delete this one because we are not going to use it. I select it and then I click delete. And after creating these two functions about the concrete we are going to use, we need also to specify the compressive strength of the two concrete. The first concrete C400 and C270. So to check what I did before, I click on modify, and then I have to select the code we are going to use to define the compressive strength, and then I have to put the compressive strength of concrete and the cement type I'm going to use. And this is the result, the graph of the compressive strength of the concrete. And for the next concrete also is the same. You input the data of the compressive strength and then the cement type you are going to use based on the code CEBFIP. And that's how we define the time-dependent material property of concrete. So we need to link this function of creep and the function of compressive strength to the material we define. So to link the material, we need to select the material here. The first material is C400. The second, for the second point is compressive strength. We need to select the same material, but this is the compressive strength of the same material. And in order to link this property to the material we previously defined, so we have to select the material we are going to link is C400, and then you need to place it here in the selected part. And then if I select this one and then I click on add, I'm going to add here the material and the creep and the function of creep related to this material, and then the compressive strength related to the concrete I defined. This is how we link the time-dependent properties of concrete to the concrete we defined in the model. And I already linked the concrete we created to the creep and compressive strength. So after doing this, then we can go to the analysis. But before analysis, we need to specify we need to change the element dependent material property, because you know that these sections are really different, because all the sections are different here from the pier to the key segment. So the time dependent property of concrete also will be different from one section to another, because they don't have the the same size and they are not built at the same time. So in Midas Civil, to deal with that, we go to the function that is called change element dependent material property. And we can find it here in the property menu. And you go to time dependent material and change property. When I click on change property here, you can see how we can change the property of the material here. So you can select the option we add and replace, and then the element dependent material, need to select the national size of member. So is the value of 8. If I change the value of 8 that I use here for the national size of member, so the software will ignore the value that we previously defined for the national size of member. That's what you have to understand when you are using this function of change element dependent material property. But here in our example, I'm going to use auto calculate. So the machine will going to calculate the age, the national size of member of each section here in the model. So you need to select this girder from the beginning. I can use this one from the beginning until the end. Then after selection of this, then you hit on apply. Then the software will calculate the section property of these sections here of the beam element we define, and each section will have its property, its time dependent property, because they don't have the same size. So that's what you need to understand in Midas Civil. It's a special feature in Midas Civil when you are doing the construction stage analysis, and it's easy to apply. I already applied this one in the model, so I will not click on apply. So I will close this. So to perform the analysis, we need to hit on run analysis, and then the software will give us the results. So after the results, we are going to finish. I'm sorry because we have only few minutes. We already did 1 hour and 10 minutes. So in 5 minutes, I'm going to make sure that we are going to finish. I'm sorry for the delay. And you can see that something that you can do in few months, the software can execute it, all the calculation you need just in few seconds. And that's the advantage of this software. So any calculation you do by hand, and it takes a lot of time, but here it's just few seconds, and that can save you time in your business. That's why we are calling you to use Midas Civil, because it's really fast and helpful in your analysis and design of structures. Okay, the analysis is completed, so we can check the different results for our analysis. First, we can check the stress variation from the construction stage number 1 through construction stage 16. So we can go to result, and then you go to bridge, and then a bridge girder. So we will going to review the stresses at the section bottom at the stage 13. So we need first to select stage 13. And from this one, we need to go to result and go to bridge girder and then click on bridge girder diagram. Then we are going to check first step and the user step. After taking this step, and then we can go to load cases. And from the load cases, we have to select the summation. The summation means the combination of all the load of the construction stage that we defined. So after that, we can select the stress as the diagram type. And after that, we need to click on the x-axis type. We need to select node. And for the bridge girder element, we need to select bridge girder. Bridge girder is here, bridge girder. And for the components, we need to select the combined. So when I select combined, it means that we are going to consider the axial and the moment combined. And for the allowable stress, we need to select the maximum. And here we have to draw the allowable stress line. We have to take this, and then we need to input this. We have to leave this value there. Then if I click on generate the generation option, I have to select current stage step, and then I click on OK. So this is the graph of the stresses variation from construction stage 13, and I just select few nodes in order to check the stresses on the structure. And the next thing to check is the stress history. To check the stress history, we need to go to result, the result, and then time history tab, and then we go to stage step graph. So I need to go here and then click on step, stage step history graph, and then we need to define new function. But as I already defined a function, I don't need this one. I need to cancel. I define the top and the bottom. So if I select these two functions I defined previously, and then I have to click on to select the step option, all step. And for the x-axis, I need to select step. And lastly, I have to check the load case combination, and then I have to select summation. And the graph title, I have to write the stress history. So for this, and then I click on graph. Then the software will give me the stress history from the construction 1 through construction 16. This is the stress history for all the construction stage analysis. So to check also for the moment, the result, and then react force, and then beam diagram, and then you can select the load case you are going to take the moment, and then you can take the legend, and then you click on apply. Then you have the graph of the moment. That's how you can check the moment as the stage number 13, the construction stage 13. Okay, to check the stress using the table, you can go to result and then result table, and you need to go to stress. Where is the beam? And then you need to go to stress. You need to click here on stress. Then we can specify the elements that we are going to check the stress. We can check 19, and then the load case we are going to use is summation, and the stage we can take stage number 1 through stage 16, and then we can check on what is the beginning of the element, and then we click on OK. And these are the different stress that we have for the stage number 1, construction stage number 1 through construction stage 16. So this is how you can check the stress in using the table result, and this table can be exported to Excel easily. You can click on export to Excel, and then you can save the file easily on your computer. And the other stuff to check is about the loss, the tendon loss graph. So for the tendon loss graph, we need to go to result, bridge, and then tendon loss graph. We need to click there, and this is the tendon time dependent loss graph at the construction number 1. So if you want to animate from the construction stage number 1 until to construction stage 16, you need to click animate. Then you will check the variation of the tendon loss from construction stage number 1 until construction stage 16. And when you check the loss, the tendon loss, you can go to, you can check also the tendon coordinate. It's the same procedure. You go to result, and then result tables, and then you go to tendon, and then you click tendon coordinate, and this is how you can check the coordinate of the tendon we use in our model. And to check the tendon elongation, you need to go to result tables, tendon, then you click on tendon elongation. And this is how you can check the tendon elongation from the beginning and the end of the element. Yes, this one is element elongation, and this one is the summation at the beginning and at the end. That's how you can check the elongation of tendon. And the other result we can check is about the tendon arrangement. For the tendon arrangement also, you can check these results related to the tendon arrangement. The other result to check is the tendon loss. The tendon loss in the form of tables, you can take it like this: the stress after immediate loss, the elastic deformation loss. You can check them also easily using this table result of the tendon like that. For the camber, because the camber also is really important when we are analyzing the reverse concrete box girder. So the camber is really important to check. So to do that, we need to go to result, and then we need to go to bridge, and then camber reaction, and we need to go to click on FCM camber, because we use the FCM wizard, so we need to go to FCM camber, and then we need to click on FCM camber control. After clicking here, then you have to click on OK. Then to check the graph of the camber, you need to go here and click view, camber graph view. Then you can click and select summation for the load, then click on OK. So this is the camber variation from for all the construction stage we have. Also, we can check the deformation of our structure. To check the deformation, we need to go to result, and then we need to check deformation, deformed shape, and then we need to select the load case we are going to use. we can select summation, and then we take the deformation in X, Y, Z. We click on legend, and then if I click on current cell placement, then the displacement will be only for the construction stage 15. But if I don't click on current displacement, so the software will give me the accumulation of the deformation from construction step number 1 until construction step 15. So let's check first the displacement for this construction stage 15, and then I can click apply. So this is the deformation. It's construction stage 15, but to check the accumulation of the deformation, you need to uncheck this back here, and then you click apply. Then you can see the deformation shape of our bridge from construction stage number 1 until construction stage 15. So if you have any question, please you can ask me, and I will reply you. Do you have any question? Okay, if you don't have any question, then you can still send me an email or a message on WhatsApp or LinkedIn, so I can still answer your question through those tools. So thank you very much for watching this webinar, and hope to see you next time. I'm going to plan another one. If God wants, then we'll continue our training with Midas Civil. Thank you very much.